Hey, let's solve some equations. But before we start, I want to solve these equations in kind of an odd way. When we get to our solution in the end, 5, the 7, 32, they're all still going to be there. There isn't going to be like, it's not just going to be x equals something at the end. There's going to be this kind of big expression at the end. I'll show you what I mean. Okay? So let's see. If I want to solve this equation, the first thing I need to do is subtract 7 from each side. Know that. So 5x equals 32 minus 7. And then I need to divide by 5 on both sides. So that would give me x equals 32 minus 7 over 5. Which we could, simplify. 32 minus 7 is 25 divided by 5 is 5. But now that expression there has the same value as 5. Right? And in this expression here, notice we can see the 7 came from over here, the 5 came from over here. We can kind of see how it came together through our equation solving process. Let's do another one. Here I'd want to add 5 to both sides first, so I'd get negative 3x equals 10 plus 5, and I need to divide by negative 3 on both sides to get x equals 10 plus 5 over negative 3, which equals 15 over negative 3, which is negative 5. But in this expression, you can kind of see where the 10 came from, where the 5 came from, where the 3 came from. They all came from this original setup here. On this one, let's see, I want to add or subtract 4 from each side. So 7x equals 11 minus, wait a minute. Let's make that 21 instead. Let's see, so 21 minus 4 is 17. Oh, except I didn't want to write it that way. I wanted to write it as 21 minus 4. So I'm going to divide by 7 on both sides to get x equals 21 minus 4 over 7. So first step was to subtract 4, and then we divided by 7. And this works out to 17 over 7, which we're just going to leave as 17 over 7. So with all these things in mind, with these 3 examples in mind, I'm going to get them all on the screen here. You kind of see how we subtract, or we add or subtract our constant term. And I could just tack that onto the end here, and then we divide by the coefficient, and the coefficient ends up down the denominator of our expression. So now, if you wanted to solve something like, say, ax plus b equals c, you just follow the same procedure, follow the same pattern to isolate the x. I'm not going to show you how to do it, but I think you can figure it out.